In section 7, we're going to be looking at inequalities in two triangles. And the main idea here is just thinking about a hinge. Now, if we think about opening a doorway, so the doors would be the same size, the wall would be the same size, but the further you open this, so the larger your angle is, the greater the distance will be over here. And that's basically what this lesson is about. And so they call this the hinge theorem because it's like opening a door and it's got a hinge here. And we're just saying that the larger angle is going to be across from a larger side. We can see this demonstrated here. If I've got a smaller angle here, comparing my angles, then the side is going to be shorter. If I open it up to be farther, a larger angle is going to give me a longer side than the other one. And this will be true even if I change my side lengths, I still will have the larger angle across from the longer side. So to use this, where you want to know which of these statements will be true, notice first of all that we have sides the same, so two sides, and then we're looking at the included angle. Since this is a 90-degree angle, and that's greater than 70, then it tells us the side across from that, SK, will be greater than the side across from this, which is YU, which would give us C. So also if we wanted to look at this one here, we have 125 and 78. Now we do need to double check for, that's good, 7 and 7. So we have congruent sides, we have the angle between them. Since 125 is bigger than 78, we know the side opposite, LN, is greater than the side opposite here, QO. We can also see this if we open a pair of scissors. If we have a larger angle, we'll have a longer side. Okay, the opposite with this would also be true. If we're comparing the sides then, the longer side would be across from the larger angle. So if we know the sides there, the red side bigger than the blue side, so the red angle is bigger than the blue angle. In this example, we're asked to find a range of possible values for x. And we'll come back to this word range. Now first, to find one limit of this, we'll be using that hinge theorem. Notice that this side and this side are congruent, and we also have a shared side. So we're looking at the angles between these sides. Now we have 60 here, we have a variable here. We need to know which one is greater. So to do that, we're going to compare with the sides opposite of this. We notice that 15 is greater than 10, so we're also going to write this then as 60 being greater than 5x minus 20. Solving this inequality, we're going to get that x is less than 16, or we could turn that around and write it this way. Okay, so we know that x is less than 16, but we don't know exactly how big it is. Now, let's go back to this word range here. Why did they say the range of possible values? Because this is the information that our hinge theorem gave us. Well, what we've got, we need to remember that an angle needs to be between 0 and 180. Sometimes in these problems we know that x is greater than something, and so we have to find the other end. In this case, we know that it has to be smaller than 16. So we also need to know that this angle 5x minus 20 has to be a positive number. It has to be greater than 0. And so my x would also have to be greater than 4 in order to get a positive number here. And so putting these two things together, this 4 and the 16, we know that x would have to be greater than 4 and less than 16 in order to give us an angle. Now the lower side, again, was based on the fact that it's just an angle. And the upper limit here was based on it fitting the converse of the hinge theorem. If we look at a similar problem, we see here that x is across from the 8, 30 is across from the 5. We have the side angle side going on. And so if I wanted to compare x with 30, we would see that x has to be greater than 30. In this case, we already have a lower limit. So when we're thinking about that x being between 0 and 180, we see that the upper limit in this case would have to be the 180. So again, just like the last one, we look for a lower limit and we look for an upper limit. So this time I'm between 30 and 180. In our next proof, we're asked to prove that BAE, so this whole angle here, is greater than BEA, which is just this part of the angle here. Now based on what we're given and the theorems that we have, we probably want to look at these two triangles here, these overlapping triangles. But notice that this angle here does not really include the part that we want. What we are going to look at instead is we're going to show that angle A here is greater than this angle E over here. Then, because this is actually split into parts, either one of these parts has to be smaller than E, which means these parts being smaller than E and this A being greater than the whole of E. Since A is greater than the whole of E, then we know that A also has to be greater than either one of the parts. But let's start now by looking at the comparison between A and E. To do that, we're going to have to recognize these overlapping parts, which is our reflexive property. Next, we are given also the relationship between the angles, and using the converse of the hinge theorem, we'll notice that BAE is greater than angle DEA. Now, the next thing we're going to do is look again at these parts that are making up angle DEA, because we're really concerned about this part. Now, if these two parts are adding up to give me the whole thing, then either one of those parts, and we are looking for BEA, it has to be smaller than the whole thing. That was a comparison property of inequality. We then compare, since we know that this DEA is bigger than that, we also know that DEA is smaller than BAE, so using the transitive property, we get that BAE has to be greater than BEA. Okay, another proof we could also look at, MON is 80 degrees and O is the midpoint. Now our definition of midpoint then tells us that LO is congruent to ON. We also have a shared side, the reflexive property here. There's other information also. We have a linear pair, so this would have to be 100 degrees. They're going to add up to 180. And therefore, this side is going to be the longer side. And so we end up with this inequality.